Hi, I'm Coursework Officer of Primary 6 from YUMIN Primary School. For this time, we're still at ordinary differential equations. For ordinary differential equations, for these times, we have been using the characteristic equations method. Well, with these characteristic equations method, we're using a lot of different examples to show us how we can use this type of method. And it will also tell us what is the advantage of using this method. So this we go by exemplification. So we have another example over here. This example is y's fourth derivative minus 3y third derivative minus 3y prime prime plus 11y prime minus 6y. And this is e to the power of 3x plus e to the power of negative 2x down to minus x cubed. Firstly, this type of problems, we first check what type of example is this. Firstly, just by checking here, it is linear. It is constant coefficient, but it is non-homogeneous. But non-homogeneous, we're finding the general solution for non-homogeneous. So we split it into general solution for homogeneous differential equation and the particular solution for non-homogeneous differential equation. In short, we'll write it as yg is equal to yh plus yp. Okay, so from here, we first find yh. Okay, yh. So that means we just take this part behind as 0. When written down, it looks like this. So from this part, you can choose to write out let that whole thing, or you can choose to straight away write it as lambda. For example, here is lambda to the power of 4. As we have used this many times, and if you want it to be short, you can just write it like this. Okay, now you have this whole thing. It's all the way to the power of 4. So you don't think that you can straight away find it at one go. So for this part, we can use our factor theorem for this. Okay, using our factor theorem. So firstly, we'll take f lambda as, okay, this whole thing. Okay, this is f lambda. After that, we have to try out. So what numbers can we try here? So usually we go positive, negative, 1, 2, 3. These are the most common whereas you will try. So what if it is 1? So actually for all of these, 1 will just give you a 0. That means lambda minus 1 is one of them. But from this part, you want to find the other part. So you're going to use the long division. Okay, so here. Okay, so this is your other part. Okay, then after that, here, times together, it will be equals to 0. Then after that, this part, we'll need to try to use our factor theorem again. But beware of that. This part, although we're also using the factor theorem, but the two functions are different. So you can use this as G if you choose to. Okay, so G lambda will be lambda cubed minus 2 lambda square minus 5 lambda plus 6. Then you have to try different numbers again. Okay, for example, we can still choose to try out 1. But it still gives us 0. So that means here you have lambda minus 1 squared. So that to find the other part, we'll need to use all this long division again. Okay, so next you get this part. For this part, you can just use the cross multiplication to find this. Okay, so this is like this. So that means lambda, you have 4 roots. But the first 2 roots will be the same. Okay, so these are your 4 roots. So we'll sub all of these back here and find YH. Okay, so this is what you'll get. Next part is yp. So for this yp, we'll also need to first let something. But from this let, we'll need to think about from this part. When we let, how can we get this part? So firstly, you have e to the power of 3x. Then you have e to the power of negative 2x. And you have x cubed. Then that means, okay, later I'll say more about this, okay? So here yp, but here x to the power of 3x we already have. So that means you need times an extra x. So here, you also have one already, times extra x. Okay, at this part, you have x cubed, and that means you have x squared, x, and a constant. Then next, we'll need to find all the way up to the fourth derivative. So let's go step by step. Firstly, this first derivative. Okay, so this is your first derivative. Then is your second derivative. Okay, wait, let me see for this. Then after that will be your third derivative. But from the back, you'll still have some more. There will be your fourth derivative. Okay, so this will be our fourth derivative. Then after that, we'll have to set them all back inside here. Then we'll find for each of them, will they cancel out or not. Okay, so I'll work them out here. So firstly, we can look at them part by part. For example, you can look at e to the power of 3x, or a times e to the power of 3x first. So firstly, for example, here is a times e to the power of 3x, so it's all these. Then after that is a times x times e to the power of 3x. Because a times x times e to the power of 3x. Then after that will be your e to the power of negative 2x. Wait. Okay, let me just close this out a little bit. Okay. Okay, so here's for bx times e to the power negative 2x. Then after that you have your c times x to the power of 3. Then after that is x squared. Then is your x. Then that will just be your constants. Okay, so this is what you get. Then, okay, of course this would have to equate. Okay, so firstly here, let's check how much of them do we have left. seems like here we have 28. And 28 here will be 1. So that means A will be 1 over 20. Then next here, these two cancel, these two cancel. So here don't have, that is B. So negative 45b would be 1. So b is negative 1 over 45. Then for this part, for this part they also cancel out. Then 6c here is negative 1. So c is negative 1 over 6. That is here. But this, because that this will be equal to 0, so it's actually 33c. So that means D is negative 11 over 12. Delta is here. So we actually can use the same way for this. Okay, so 6e will be 22d minus 18c, but actually you can simplify it. So when you simplify it, it's like this. So E. But for this part, okay, so E is, here's a negative. So E is a negative 103 over 36. And the last part for this is 6f. Now this 6f, from this part, use it the same way. So you get something like this. But after that, if you know everything stuck inside, it might seem too complicated. So for these types of questions, we need to use a calculator to help us solve. Because you don't have to just keep on writing those calculations. Okay, so let's see. We need to solve C, D, and E. Okay, so these three are those what we need. But of course at last you still have to divide it by 6. So that means for these parts, okay, just write it into the calculator. Okay, so it seems like that here it says negative 827 over 216. Okay, so this is what that is calculated. Okay, so next, after this, so we've already found that all these constants that we need here. So the next step is to find YP. YP, let me just sub everything back here. Firstly, 1/20. Okay. Wait, but you have to be careful, some parts are minus. Okay, so YP is like this. Then after that, for the final part, it's just to add these two together. So that means you get YG. So YG over here. So this YG is firstly this part, secondly is this part. But some parts, for example, e to the power of 3x. Here e to the power of 3x. You might want to combine them together. And you just factorize the e to the power of 3x. Okay, for example, here e to the power of negative 2x, you also can choose that. Wait. Okay, so this should be the answer that you get. Okay, so we found the solution. So overall, the most important part is here when you use characteristic equations. So what's this advantage of characteristic equations? Well, this advantage is just that from you calculate this linear, constant coefficient, homogeneous, ordinary differential equation, it just becomes that it becomes, you just need to calculate for an algebraic equation with one variable only. Well, just as simple as that. So it becomes from all these very hard things just to a very simple thing. Okay, so for this lesson, I'll end it here. So if you like our videos, don't forget to subscribe to our channel, and thank you for your watching.